So, these are our zeros. Okay, so again, you got to think we're kind of working backwards now, like we did for the warm-up and stuff like that. You can kind of think we have all this work that we did, right? We used synthetic division, we divided things out, we guessed and checked all the zeros, and we ended up with this answer. X equals 1, x equals -1, and x equals 2 as our zeros. Okay? We've got some polynomial, f of x, when it's equal to 0, that then results in these 3 zeros. We want to come up with what that original polynomial might be. Okay. So, what is a factor that would give us x equals 1? X minus 1, right? If I bring this 1 back over, which I know sounds kind of weird, but if I bring that 1 back over, now that factor, I have a factor equal to 0, right? And then what about x equals -1? Well, we get plus 1 back over. So x plus 1, again, it's equal to 0. And then that x equals 2, what would that become? Yeah, x minus 2 equals 0. So there are my 3 factors, right? Imagine now, what do? Normally you take your polynomial, you factor it, and you set each one of those factors equal to 0. Right? Well, here are those 3 factors. They're already set equal to 0 for us, right? We made them now equal to 0. So then to create this polynomial, what should we do with these 3 factors? Yeah, we're going to just put them all together. We're going to multiply them all together. That will create our polynomial. So here, x minus 1 times x plus 1 times x minus 2. And that's going to equal 0, because again, you know, the whole thing was equal to 0, so each factor is equal to 0, so it's the whole product equal to 0. Okay? Is this, so will this, well, first of all, will this multiply back together to give us a polynomial? Yeah, it will. Is it the least degree? Like, is it possible for us to come up with a polynomial of a, like, what will the degree of this polynomial be when we multiply it all out? A cubic, or 3, right? Is it possible for us to have a smaller degree polynomial to have these 3 answers? Okay, but then by the fundamental theorem of algebra, we would have fewer zeros, right? If we have 3 zeros, then we need to have at least a degree of 3. We need to have at least a degree 3. So this will be degree 3, so we're good to go. That's going to be the right side. Okay. Will our lead coefficient be 1? Well, we have a lead coefficient of 1 here, a lead coefficient of 1 here, a lead coefficient of 1 here. 1 times 1 times 1 will end up being a positive 1. So yes. Okay, so this is going to result in the polynomial that we want. Okay, so now we just have to multiply this together. Okay. To multiply this together, Jake, how do we multiply this stuff together? Well, how should we go about doing that? Okay, so you want to so which things are you which x's are you multiplying here?
Like the first one by the
it's like these 2 right here?
Yeah.
Okay, so we'll FOIL these out. Exactly right. So we get x squared, let's see, minus 1x, but then plus 1x, and then minus 1. And we still have that x minus 2 there. Okay. We have some like terms combined, don't we? -1 and positive 1x, they're going to cancel out. We'll have to just x squared minus 1 times x minus 2. Okay, just like that. And then, Jake, how do we continue to multiply here? What should we do now? Yeah, actually, we can FOIL again here, because it's kind of 2 binomials all over again. So it'd be the first, x times x squared is x to the 3rd. The outer, minus 2x squared. The inner, minus 1x. And then the last, plus 2. And so there is our mystery function. X cubed minus 2x squared minus 1x plus 2. Okay, that will have zeros at 1, -1, and 2, because that's how we wrote it. We wrote it that way. We use those zeros to come up with these factors, multiply the factors back together, and we end up with that polynomial. Okay? Do you guys know how to use your graphing calculators to figure out the zeros of a polynomial? What's that? Don't need to use the matrix. Nope, we can just graph it. Yeah, watch this. I'll show you here real quick. All right, I didn't show you guys this before, but I'll show it to you now. You're gonna be like, Mr. Wid, I hate you. It's okay. This is my St. Patrick's Day present to you guys. All right. So there's the polynomial. You type it in. You just hit graph. And look at the zeros. You can see where they cross, right? One crosses at -1, one crosses at +1, one crosses at 2. And if you don't believe me, you can press second trace, use the 0 command. See, it says left bound question mark. That means you want to go to the left of your 0. So let's see if we can find that 0. So go to the left of it, hit enter. Go to the right of it, hit enter, and then guess. You want to go in close to it. Hit enter, and boom, there it is, -1, 0. You can look at the table too. Yep, that's another option. Yep, and then if you go to the left here, the right here, go in and guess. 1, 0, there's the other 0. And then the last one. 2, 0. Okay, so you can see all the zeros there. And yeah, you can check your table too. Let's see, I have to change my table back to auto. We can see them that way. So like a 0 at, well, there's -1, 0, 1, 0, and 2, 0. Okay? So, questions on any of that? Alright, let's try another one. Because not all of our zeros are nice rational numbers like 1, -1, and 2. What happens if we have zeros of, let's change up here, 3 and 2 plus or minus the square root of 5? See, we want to come up with this function that has those zeros. All right, well, that means we have one that x equals 3, and then we have another one that is x equals 2 plus or minus the square root of 5. Okay. So if x equals 3 is our 0, what's the factor that would give us this? X minus 3, right? We subtract 3 from both sides, we get x minus 3 equals 0. Okay, so there's one of our factors. For this one, I'm going to show you a little helpful tip here. All right, for this one we kind of have some trouble because of that square root, right? We don't like that square root. It's messing things up. So let's just subtract the 2 over. Make it x minus 2 equals plus or minus the square root of 5, like that. Since that square root is giving us trouble, how can we get rid of the square root? What cancels out a square root in an equation? Square both sides, right? So when you square a side, right? We can't just like pick and choose. So we don't want to square in the very first step here because then we have to like FOIL this thing out. Instead, we want to subtract the 2 over and then square both sides. We isolate that square root. Like that. Now when I square the square root, it will perfectly cancel out. What's the positive square root of 5 squared? What's that going to give us? 5. What's negative square root of 5 squared? Still 5. So that means we don't have to even worry about the plus or minus anymore. Now to square this out, I need to FOIL, right? Because it's really like x minus 2 times x minus 2. And so I get x squared minus 2x minus 2x plus 4. And so I get x squared minus 4x minus 1 equals 0 when I subtract 5 from both sides. So, whoa, there's the other factor. X squared minus 4x minus 1. Okay, and so we'll just take x minus 3 times that x squared minus 4x minus 1, and then we just multiply this thing up. Okay. Can we use FOIL to multiply these two things together? Not really, no. Okay, but just distribute. X multiplies to everything here, so x times x squared is x cubed. X times minus 4x is minus 4x squared. X times minus 1 is minus 1x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 4x, positive 12x. Negative 3 times negative 1, positive 3. and then combine like terms. And there is our polynomial. Okay. Oop, I lose it. Questions on any of that? Anger's frozen on the screen now. Alright, do one more here. We'll throw some I in now, some I's in. Okay. Let's try another one. Let's say now we've got zeros of let's say it's got zeros of 2 and plus or minus 3i. And plus or minus 3i. Okay. So that means, right, x equals 2 is a solution, and x equals plus or minus 3i. Those are also solutions there. Okay. Carlos, if x equals 2 is an answer, right, what's a factor that would give us x minus 2? Or what would give us what's the factor that would give us x equals 2? A factor, yeah. So in other words, like here, when we had x equals 1, that was an answer, right? We were told it has 0, 1. So the factor that gave us that is x minus 1. So what's that? X minus 2 equals 0. Exactly right. That's our factor. Okay? Very good. Here, with the imaginary numbers, we can kind of do something similar to what we did here, the square roots. You see how we brought the 2 over and isolated that square root, the plus or minus square root? Remember, I is a square root of what? Negative 1. So that means I could write this as, instead of 3i, 3 square root of negative 1. And now, just like I did down here, right, we had the square root kind of by itself. Right here, the square root's basically by itself. We can square both sides. So let's square both sides here. X squared, that's easy, it's just x. I square here. Sorry, it's just x squared. What's 3 squared, Carlos? 9. And the square root of negative 1 squared is going to be what? What's that? Square root of negative 1, but then squared. It would be negative 1. It would be negative 1. It would be the square root of negative 1 squared. The square and the square root will cancel, but the left of the negative 1. And so then it becomes negative 9. So x squared equals negative 9. Which then, to make that a factor, we'll add the 9 over to make it equal to 0. And there is our other piece. Okay. So it'll be x minus 2 times x squared plus 9. And again, equal to 0. So we took those 2 factors, and now we're just going to multiply them. And now you can use FOIL, right? We can use FOIL here. So it becomes what? X cubed. So the outer would be plus 9x minus 2x squared minus 18. And now I'll just put it in descending order. And there it is. There's our polynomial of least degree. Again, it's got a degree of 3. There's 3 roots. From like here to here? Point 2. Oh, I see what you're saying. You want me to do something like that?
No, it says 0, no, 0 is 3 and 2 plus or minus.
Oh, this one. Okay, I'm sorry. I see what you're saying now. Okay. That's okay. Okay, you can see that part. I got you. Okay. Okay, and that's basically the three different kinds of problems you could run across. Either you'll have all rational roots like this, which then you just, make them equal 0. So subtract the 1 over, add the 1 over, subtract the 2 over, and get these three factors, and then just multiply those three factors together. Okay, multiply 2 first, and then combine like terms, and multiply again, and then that's your final polynomial. If you have square roots, or I, which is really just a square root, set the x still equal to that 0, but then in this case, bring the 2 over so the square root is isolated, then square both sides. Okay, and so then x minus 2 quantity squared is just x squared minus 2x minus 2x plus 4, which is x squared minus 4x minus 1, when you bring that 5 over. Again, when you square the square root of 5, it becomes just 5. So you can bring that 5 over there and get that. Okay, same thing with the I, right? The I was already kind of by itself here, so we just squared both sides. We got x squared equals, and then the square of 3 square root of negative 1 is 9 negative 1. So you get x squared equals negative 9, add it over, and then you got your two factors that are equal to 0, so you multiply them, and blah, blah, boom, there you go. Ba-doom. All right, you guys ready to try one?
Yep.
Yeah, okay, here. Yeah, that's the spirit. All right, so here, you guys try this one. Okay. Zeros of 4 and 1 plus or minus the square root of 5. Okay, so come up with a polynomial function that has those zeros. Okay. So see if you can come up with the polynomial that has those zeros. Okay. We're trying to come up with the factors first, and multiply those factors together. Get stuck, we know. We're going to help some. You feel like you got it okay, Rick? Yeah. So, perfect. You want to square this side too. Okay, so what's this going to be when you square it? Right, but since they're squaring it, so if let's say it's plus root 5 squared, that means it'll be positive root 5 times positive root 5, which is 5. And then it's be 5 regardless, exactly. So the plus or minus you can kind of throw out. So it's really just 5 on this side. And then x minus 1 quantity squared, well, you have to multiply, you have to like FOIL that out. You know what I'm saying? Because x minus 1 times x minus 1, and then bring that 5 over, and then you multiply x minus 4, x minus 4. Looks good. Okay, so close here on this, but not quite. So if you have the 1 plus or minus root 5, subtract the 1 over. Okay, this is your these are your zeros, right? 1 plus or minus root 5. Subtract 1 over. Square both sides. Okay. What's this going to be when you square? Just d5. And this will be Okay? And then you can bring the 5 over, and then so we get x squared minus 6. Or x squared minus 2x minus 6. Oh, yeah, I forgot. When you square x minus 1, it's not going to be x squared minus 1. Remember, when you square x minus 1, like this right here, that's really x minus 1 times x minus 1, which then has to FOIL out. And so you're actually going to get this. Okay? Sorry about that. That's it has to be right there. Okay? No, you got to think about it. Okay? So, what's this going to be when you square it? Just 5. X equals 5. And then when you square this, you have to FOIL it out. It's really x minus 1 times x minus 1. You see what I'm saying? When you square x minus 1, that means x minus 1 times itself, another x minus 1. Take it. Well, so, answer your question. What I mean is, right, if you square something, that means you multiply it by itself, like that. And then you FOIL it out, and then bring the 5 over, and then multiply that by that. Okay. Okay, right there. Bring that 5 over now. Subtract the 5 over.
I bet I know.
Well, you can kind of drop parentheses at this point. There's nothing left to do outside of it.
Is it the one you gave us on it?
Okay. So you just basically subtract that from the...
I know somebody that works there.
Yeah.
Who? Adam, and his mom. I forgot his name. There's one, but she speaks like super loud. Okay, no. And they have like, I don't think he does. No, he doesn't.
Okay. So, zeros for 4, and 1 plus or minus the square root of 5. Okay. Subtract the 4 over, we get x minus 4. Okay. Subtract the 1 over to isolate that square root, and now what should I do to both sides here of this little factor or equation that we're doing? What should we do at this point? Square, that's right, because we want to get rid of that square root. So we square both sides. X minus 1 quantity squared is x minus 1 times x minus 1 there. And so you want to make it then x squared, it'll end up being x squared minus 2x plus 1. And then the square of root 5 is just 5. Subtract the 5 over, like that. So there are two factors, x minus 4, x squared minus 2x minus 4. And then we multiply those together. So these are a lot of work, but they're nice because you don't have to guess and check, right? You kind of just know, I mean, there's no like guessing involved. You already have the zeros, you're then going to make a polynomial from that. So we multiply these out here, and oh my goodness, let's see here, minus 2x squared, minus 4x, minus 4x squared, minus, plus 8x, plus 16. And so we get x cubed minus 6x squared plus 4x plus 16. Okay, and so there's our polynomial. And you multiply it out and combine the terms. Okay. All right, so we focused on cubics that don't, like, not a specific cubic. Like, we're okay. There's actually like an infinite number of possible answers here, okay, for these problems. With the way, well, not with the way they were written, I guess. There's only one kind of answer to the way they're written. All right, but we can find specific, functions too. So, for example, how many points does it take to determine a line? How many points do you need on that line to determine what the equation of that line is? How many points do you need? 2, right? You need 2 points on the line to write the equation on the line. If you guys remember, we talked about this before. How many points do we need for a quadratic? sometimes we've given 5 or 6, but we only need 3. We only need 3. Okay. Say again?
One more than what?
Essentially, yeah. We only need 3. And then, for a cubic, how many points do you think you need? What's the minimum number of points? 4. Yeah, you need 4. Okay? You need 3 zeros, and then you need 1 more point to determine what the lead coefficient's going to be. Okay? So that's like that. I'll just show you a quick example of that here. So for example, I'll use just a different piece of paper here. Okay. Let's just say we want to, and this will be our last problem. I'll give you guys your assignments here. Say again. Oh, 3's on. Darn it. Thank you. Okay. So let's say we want to write the cubic function graphed below. Okay. Now, granted, it's not just any 4 points, right? So again, a cubic needs 4 points to write the equation of it. It's not just any 4 points. We need 4 kind of specific points to help us out, at least for our calculations and things. Okay, so I'm just going to sketch a graph here of this cubic function. Okay, so 1, 2, 3, 4. Okay, so it's going to have a 0 at -4. At +1, and at 3, and it has a y-intercept of -6. So 1, 2, 6. Okay, and so it's going to look something like this. So if you can get the 3 zeros of a cubic and then any other point on the cubic, you can come up with a function very easily. All right. So again, we got -4, 0. We got the point 1, 0. And we got the point 3, 0. Okay. So it shouldn't come as any surprise here. Okay. Since our 3 zeros are -4, 1, and 3. If our 0 is x equals -4, what's a factor? X plus 4, right? This is what we just did. If a 0 is x equals 1, then the factor would be what? X minus 1, and then the x equals 3 would be x minus 3. So there are 3 factors. The only difference is here, I'm going to put a little a out front. Okay. Put a little a out front here. Why did I put an a out front of the previous problems? Well, the previous problems, the direction specified what was the lead coefficient. It was 1, right? If you remember, because we didn't talk too much. I mean, we wrote the directions out, but we didn't say. But write a polynomial function f of least degree that has rational coefficients, a lead coefficient of 1, and we had all those zeros and stuff like that we did. Here, we're not specified that this lead coefficient is 1. In fact, we don't know what it is. That's why we're going to use the a here. Okay. So we have everything that we need. We have all the zeros set up. We just need to figure out what that a value is. And that's where that other point comes in. We know the y-intercept is 0, -6. So how can I use that? How can we use that to help figure out what the a value is going to be here? What can go where? -6 in for y. And what goes in for 0? Where does 0 go? And for the x. So it'll be -6 equals a times 0 plus 4 times 0 minus 1 times 0 minus 3. So that's going to be 4 times -1 times -3. So let's see, that's going to be positive 12. And then finish solving. What do we do? A times 12 equals -6 divided by 12. So a is negative 1/2. And so on this one, I'm not going to make you guys multiply it out. You can just leave it like factored or whatever. But negative 1/2 x plus 4 x minus 1 x minus 3. So there's the cubic function for that specific graph right there. Okay. So in this case, we weren't told to assume the lead coefficient was 1, but we could come up with it using that fourth point. All right. So let me give you guys some problems to do here for your assignment. All right. Darn, I wish they would do, well, okay. All right, so here's your assignment. Give it to you here. It's going to be from 2 different sections. We kind of did two different sections here. Well, not to get it done. 10 minutes? What are you talking about 10 minutes? Okay. So I'm going to have you guys do page 384. It's in the green book, yeah. And I can write them up too if you want. (21, 28), and then page 397, number 3. Okay. Let's see here, and I'll try and write these up on the board. They're not that easy to write up on the board, so you may just want to take a picture with your phone.